Hi, I'm Reverend Greg and I welcome you to this video in the tutorial series Shaders for Hobby Programmers. It's finally time to look at a new, very important concept of shaders. We'll start using coordinate systems. There's different coordinate systems to use. Today we're looking at glFragCoord and InPosition. In a later video we'll also look at VVTextCoord and coordiante. As always, a short disclaimer. This tutorial series is mainly for hobby programmers who struggle with understanding shaders. I'm not a professional programmer and I'm not very good at maths. So if you see any mistake in my video or see a better way to solve a problem, please add a comment so everyone can learn from you. So without further explanations, let's dive right into coding a starting setup. By the way, the coding is not really the important part of this video. This video is about understanding the coordinate systems. So if you don't feel like typing a bunch of code, you can just watch me doing it and observe what happens with every change. Let's start by creating a new shader and call it Shader Test FragCoord InPosition. In the Vertex Shader, we can remove InColor and VVColor in the header and inside the main function. But we need to add a different varying vec2 VVPosition. And we need to pass it to the Fragment Shader by setting it to InPosition. Note that we need the XY because InPosition is not a vec2 like VVPosition is. But that's all for the Vertex Shader, so let's close it and look at the Fragment Shader. In here we can remove VVColor from the header and inside the main function. And let's split the line in the main function as I always do. But this time I'll declare base col as vec3 and just grab RGB from texture2D. vec3 base call is texture2D of GM base texture at vvTextCoord.rgb. And in the glFragColor line, we'll just set alpha to 1. Before adding to this shader, let's continue with the object. First, I'll copy the module template inside the base project and call it Object Test FragCoord InPosition. As always, I set up the standard things like info text, sprite, and shader. Now for this test, I'll also change the way this module works. These changes are only needed if you're using the base project and can be ignored otherwise. First of all, I'll change the object sprite to sprite frame wide, because the sprite I'm using is not square as usual. Then I'll set the system to select this object when created. Global.selected module is ID. For this test, I want to be able to drag our test object and the view. To do so, I'll add two new variables. Dragging view is false, and dragging frame is false. And for dragging we also need a step event. Now I'm not going to explain that code in details. This tutorial is about shaders and not about dragging. First, let's set up the controls for dragging the view. Since I want this to work on my tablet as well, and I'm going to use the right mouse button to drag the view, I'll need to change the button to stop dragging on the tablet to MB left. So I can start dragging on the tablet with double tapping and stop with releasing. Drag view controls. If OS type is OS Android or OS type is OS iOS, var button is MB left. Else, var button is MB right. If device mouse check button pressed, device 0, mouse button right, then dragging view is true. Drag view delta x is camera get view x of view camera 0 plus device mouse raw x, and drag view delta y is camera get view y of view camera 0 plus device mouse raw y. And to stop dragging, if device mouse check button released device 0 button, dragging view is false. Just pause the video if you want to copy the code. Now the controls to drag the object. This code will only work if the object has a sprite, but if you're using the base project, we just set the sprite to sprite frame wide anyways. Drag frame controls. If device mouse check button pressed, device 0 button left, and collision point mouse X, mouse Y, ID false false, then dragging frame is true, drag frame delta X is X minus mouse X, and drag frame delta Y is Y minus mouse Y. If device mouse check button released 0 left, dragging frame is false. So this code drags the object using the left mouse button. Now the actual dragging. If dragging view, then camera set view position of view camera 0 at drag view delta X minus device mouse raw X, and drag view delta Y minus device mouse raw Y. Else, if dragging frame, X is drag frame delta X plus mouse X, and Y is drag frame delta Y plus mouse Y. Now in draw event, let's just make sure the sprite is drawn through the shader. Now the room. I'll just create a new child of the template room, name it room FragCoord XX in position, and for now move it to the top of the list. If you're using the base project, there's an object labeling each room based on the room's name, and that object will replace XX with a vertical line. Now inside the room, I'll place the new object on the main layer. But for this test, we also need to increase room size. I'll set it to 2016 times 1056. And on the tile layer, I'll just fill everything with the lighter tile and create a frame and a cross through the center with the darker tile. Now for our test, it's important that the cross really goes through the center. If you're using the same dimensions and a 32 pix grid, then the center will be at tile map coordinate 31, 16. Let's close the room, run this, and test the dragging. Left mouse button on the object drags the object, and right mouse button anywhere in the window drags the view. So this setup works. Now back to the fragment shader. Let's just set the color channels to VV position X. Base call is vec3 VV position.x. This also means we need to grab the varying vec VV position from the vertex shader. Varying vec2 VV position. And let's run this again. As you can see, the sprite is now just white. So this means our shader is drawing every pixel with a luminance of 1 or higher. This also won't change if we drag the object or view around, except when we move the view to the right and the frame across to the left side of the room. This means VV position is not a value ranging from 0 to 1. Its X is 1 or less unless we reach the left side of the room, then it's 0 or lower. So let's just divide the X coordinate by 1000, VV position.x divided by 1000, and see what happens. Now we see a gradient, and it seems the channels turn white 1000 pixel into the game or view, and they turn black on the left side of the game. So we see VV position is a coordinate system based on pixels. And notice that the gradient moves with the view. If we drag the view around, the gradient moves with it. But what about glFragCoord? Let's change the code to show glFragCoord.x. So glFragCoord.x divided by 1000. The first thing you might notice is GameMaker doesn't recognize glFragCoord as a built-in variable, at least not at the time I'm recording this, but it works anyways. So let's run the program again and see what happens. Again we see a gradient from black to white, and again the coordinates seem to be in pixels. But if we move the view around, we notice the gradient is not moving with it. So this tells us the coordinate system is not tied to the game world. It's hard to understand those two systems with this information, so let's improve our code to better visualize what happens. What I want to do is colorize the coordinate system. Every pixel at the border of the coordinate system should tint the photo blue. Every pixel in the upper right quadrant shall be red, every pixel in the lower left quadrant shall be green, and every pixel in the lower right quadrant shall be yellow. And to test this properly, we need to test different dimensions, like the dimensions of the window or the display and so on. So back in the creative end of our object. First we need two uniforms. The handler uDimensions for the uniform dimensions. This will be an array holding width and height of our coordinate system. And the handler uShaderCoord type for the uniform ShaderCoord type. This will tell the shader to either use glFragCoord or VV-Position. Now we need to set up and fill the dimensions array. I'm just creating an array called dimensions. It's a 2D array and the first position will be the coordinate system type and the second will be the width, the height and the name of the system. And I'm going to create an array for hard-coded values. For the Gui dimensions, the window dimensions, the display dimensions, the application surface dimensions, the room dimensions, and the view dimensions. And we also need a variable coordinate system which stores which of these arrays we're currently using. And I'm also setting the size of our GUI layer to something different. Now in step event we need to choose which dimension we're using. In the base project we can just use global.slider1 to do that. Set coordinate system. Coordinate system is min floor global.slider1 times array height 2D dimensions, array height 2D dimensions minus 1. But if you're not using the base project, just set coordinate system in creative end to a number ranging from 0 to 6 and run multiple times, or create a system in step event that lets you set the number from 0 to 6 based on, in example, key presses. Now in draw event we need to pass the uniforms. Shader set uniform F, handler is uDimensions, and the values are dimensions coordinate system 0 and dimensions coordinate system 1. That's the width and the height of our coordinate system. And shader set uniform F, the handler is uShaderCoord type, and the value is round global.slider2. This code will either return 0 or 1, and our shader will pick glFragCoord or VV-Position based on that. Again, if you're not using the base project, just set 0 for glFragCoord or 1 for VV-Position. Now I want to get some more information to the screen. I'll use a script from the base project, script draw corner info, to display information on the uniforms we send to the shader. I'll just create a variable called text, which shows the dimensions we're using and width and height. And whether we're using glFragCoord or in position. And I'll pass that text to script draw corner info. Now to evaluate shader chord type, I'll just round global.slider2 again and set it to in position or glFragCoord based on whether it's 0 or 1. So we want to know if the shader is using VV position or glFragCoord, and we want to know what dimensions we're passing to the shader. The last thing we need to do is make the fragment shader actually use these uniforms. First we need to declare the uniforms. Dimensions is a vec2 holding width and height of our coordinate system, and shader chord type just determines what coordinate system we're using. Uniform vec2 dimensions and uniform float shader chord type. Next, inside the main function, we set which coordinate system we're using, either glFragCoord or VV position. Vec2 shader chords. If shader chord type is 0, then shader chords is glFragCoord.xy, else shader chords is VV position. Then we set the overlay color to colorize a blue border around our coordinate system and the 3 red, green and yellow quadrants. What this does is setting the red channel to 1 if we are on the right side of our dimensions. Sets the green channel to 1 if we're on the bottom half of our dimensions, and just set the color blue if we're 16 pixels close to the border of our dimensions. Last thing we need to do is mixing the base color and the overlay. Now let's run this again. Oh, I forgot something. In order to get a better feel of what's happening, I wanted to reduce the height of view to 2/3. So in Create Event, I set the view size to that. Now let's move slider 1 all to the left, the hard-coded dimension. 1280 times 720, and slider 2 to the right so the shader is using VV position. Now what I want is to find out how to think when using VV position, or rather in position, since VV position is just an interpolation of in position. So right away we see the center of our coordinate system is just beneath the center of our game window. We see the border of our system is there as well, since we can see the blue border there. And if we move the view, we can see the coordinate system is moving with it. And if we move the object to the right, we begin to see the border of our coordinate system again. This doesn't make sense yet, so let's try the same by using different dimensions. The Gui dimensions. We had set the Gui size to half the hard-coded value, so 640 times 360. So the result looks logic, but not helpful. The window looks exactly the same and is the same as the hard-coded values. Not helpful either. Display. This looks off and doesn't help to understand this either at the moment. Application surface. Again looks and is the same as our hard-coded values. Room. It seems the origin of our system lines up with the upper left of our game again. Now this looks interesting. The quadrants line up with the room. The center of our dimensions is the center of the room. The right border of our system is the right border of our room, and the bottom lines up as well. So here's the conclusion then. In position is based on the room coordinates. Now let's move slider 1 and 2 to the left. We're back to hard-coded dimensions, but this time using glFragCoord instead of in position. This looks the same as before. The center is just beneath the center of our view, but if we move the view, you'll notice the coordinate system doesn't stick to the room. If we move the object to the upper left corner and the center of the game window, we notice the coordinate system hasn't moved at all with the room. Also, if we move the object to the lower right corner, we notice our coordinate system seems to end at the right side of our game window, but not at the bottom of our game window. So glFragCoord cannot depend on the room, and it cannot depend on the game window. But at the same time, having the center of the coordinate system below the center of our game window isn't helpful, so let's check other dimensions. Gui. Again, this behaves somehow logic, but isn't helpful to understand. The window, again, is the same as the hard-coded values, so it's not helping either. The display is again off and doesn't help me understand what's happening here either. The application surface again is just the same as the hard-coded values and is not helping. And room, we already know, room dimensions will be wrong. So there's only one setting left. View. We changed the view height to 2/3 before, and now we can finally see the glFrag color makes sense. The center of our coordinate system lines up with the center of our view, and so do all the corners. If we move the view, we can observe the coordinate system still sticking to the viewport and not to the room. So in conclusion, we can say, if you want a shader to calculate something based on viewport coordinates, you can use glFragCoord for that. Now, of course, in most cases, viewport, application surface and window will be the same, but just to be sure, always think of them as coordinates on the viewport. Now let's just see if this works the same on Android. I ran this on a tablet and it does work still if we use the same two coordinate systems. So this is the tablet in landscape, glFragCoord and view. This is in position and room. This is the tablet in portrait. And it all seems to work as well. Since we now understand that in position is based on room space and glFragCoord is based on view space, let's have a look at the Vertex Shader again. Because now we're also able to read in the code of the Vertex Shader what we just observed in this video. The vertex attribute in position is the position of the vertex inside the room. We actually already learned that in the very first video of this tutorial series, in the introduction video. But we never had it visualized before today's video. Now inside the Vertex Shader, object space position is grabbing the vertex attribute in position and then is transformed by the transformation matrix world view projection. What this means is GameMaker Studio provides us with a transformation matrix which transforms the vertex position from world or room space to view space and passes this transformed coordinate onto the fragment shader with the built-in variable GL position. And as far as I can tell, glFragCoord inside the fragment shader is just an interpolated value of GL position from the vertex shader. This explains why glFragCoord is in view space and in position is in room space. Sorry for making such a long video about this simple concept, but I think several viewers wouldn't have understood that explanation without having seen the coding and result first. I most likely wouldn't have understood it if I hadn't written today's shader when I tried to understand GLFragCoord and in position myself. I had a lot of trouble understanding all of this, and this example really helped me wrap my mind around those two coordinate systems. I hope you learned a lot here as well and enjoyed this video. In the next video, we'll start using those coordinate systems. Until next time.